First, let's discuss about fundamentals of fluid flow. We all know that discharge discharge is represented by Q. Q is equal to AV. That is the volume flow rate. The unit of that is cubic meter per second. And then M is equal to the density times the Q, or the volume flow rate. This is called mass flow rate, wherein its unit is kilogram per second. Another one is W equals the unit weight times the flow rate Q. This is called weight rate. This is in terms of Newton per second. Continuity equation. In the continuity equation, sabi dito, yung flow rate na pumapasok at this point, although maliit siya, and this part, malaki siya, yung flow rate na pumasok dito, equal siya dun sa flow rate na lalabas. Kahit na ito ang maliit ang kanyang size or yung diameter, ito naman ay malaki, mababalance na ng kanyang velocity. Okay? Kapag maliit yung ating diameter, masasabi natin ang velocity niya mabilis. Imagine yung hose, ang gawin ninyo, ipitin nyo siya. Okay? Biglang bibilis yung flow. Okay? Biglang sisirit. Kapag naman lumaki, so lumaki ang diameter niya, bumabagal naman yung flow niya. Doon nababalance yung ating diameter, kaya nasabing yung ating flow rate sa point 1 ay equal din sa flow rate na lalabas sa point 2. Okay? So since Q1 is equal to Q2, we can say that A1 V1 is equal to A2 V2. Next, energy heads. Sa energy heads, kung matatandaan nyo pa ang ating tatlong energy heads, okay? The velocity head, V squared over 2G. Okay? The P over the unit weight, that is the pressure head. And then the letter Z, that is called elevation head. And yung tatlong yan, that is represented by Newton meter per Newton of fluid flowing. Or minsan, sinasabi na lang tong meter, like distances or height ng inyong flow. Imagine meron tayong pipe and then meron nag-flow dyan. This is our datum line. Okay, mula sa datum line papunta dun sa point na yan, that is called elevation head. And then sa ibabaw niyan, that is called the pressure head. And then sa pinakamataas, that is the velocity head. Laging ang elevation head ay nasa taas ng ating pressure head. Ang ating pressure head ay always nasa taas ng elevation head. Okay, yung tatlong yan yung ating mga energy heads, E. For Bernoulli's energy theorem, sabi ni Bernoulli, so yung point 1 to point 2, equal yan. Yung energy 1 na pumasok ay equal sa energy 2 na lalabas. Kaso nga lang may dinagdag si Bernoulli dito, si paring Bernoulli. Okay? The energy added and the energy loss or extracted. Mamaya malalaman natin kung ano ba yung mga energy added and energy extracted na sinasabi na yan. So, Bernoulli's energy theorem. So, energy equation without head loss. We have this pipe from point 1 to point 2. Okay, yung papasok yung flow natin, any fluid. This is our datum line. Okay? For point 1 to this datum line, masasabi natin that is our elevation head, Z1. Dito naman ay Z2. Gaya ng pinag-uusapan natin, energy equation na walang head loss. Okay? Pagdating dito, this is our pressure head. Pressure head 1, pressure head 2, and then yung nasa taas, that is called the velocity head. Okay? Lagi nyo lang tatandaan, baka lumabas din sa mga quizzes or exams ninyo, at lalong-lalo na, lumalabas din to sa board exam. Okay? Etong ating velocity head plus pressure head plus elevation head, that is the energy grade line. Tandaan na yung point from velocity head, ng una natin at velocity head ng second pipe, that is energy grade line. Kapag naman yung pressure head ng una at ang pressure head ng pangalawa, kapag pinagpantay natin, that is called hydraulic grade line. Okay? Next, energy equation naman with head loss. With yan. Okay? With head loss. This is our point 1 and this is our point 2. Again, may flow ulit na fluid dyan and this is our datum line. Meron tayong elevation head 1, elevation head 2, pressure head 1, pressure head 2, and then sa taas nila ay yung velocity head 1 and velocity head 2. Again, anong tawag dun sa velocity to velocity? That is called energy grade line. Pressure to pressure, that is hydraulic grade line. And then kung mapapansin nyo, ang pinagkaiba nila, yung sa energy equation without head loss, ay nabuo yung ating parang rectangle. Kung mapapansin nyo, rectangle. Dito naman naputol. Okay, may kumagat sa part na to. Sino kaya yung nagutom na yan? Yung part na yan, yung missing na yan, okay, that is called head loss. Okay? Yung head loss na yan, okay, nako-compute yan base sa ating different equations derived using experimentation. So, sa una, E1 daw ay equal to E2, wherein yung velocity head 1 plus pressure head 1 plus elevation head 1 ay equal sa ating velocity head 2 plus pressure head 2 plus the elevation head 2. For the second energy equation with head loss, energy 1 is equal to energy 2 plus meron tayong head loss from 1 to 2. So, kung ililipat natin, transpose lang natin yung head loss papunta dun sa kaliwa. E1 minus head loss 1, 2 is equal to energy 2. So, we can say that velocity head 1 nung una plus pressure head nung una plus elevation head nung una minus the head loss ay equal sa velocity head ng pangalawa plus pressure head ng pangalawa plus elevation head nung ating pangalawa. Okay, next. Oops. Okay, next we have energy equation naman without or with pump. Sorry, this is with pump. And then this one is energy equation with turbine. When we say pump, so punta tayo sa ating example. So dito na lang. Okay? Pump, when you say pump, so imagine yung water source natin galing sa ilalim, paano nakakaakyat yung tubig natin sa mga water fountain dun sa bawat floors ng FEU. So, paano tayo nakakainom doon? So, ginagamitan natin yun ng pump para umakyat papunta sa taas at lumakas yung pressure ng ating tubig. Okay? Kapag ginamitan to ng pump, we have velocity head ng una plus pressure head ng una plus elevation head ng una minus yung head loss natin plus head added since nag-add tayo ng pressure, okay, that is plus head added equal sa velocity head ng pangalawa plus pressure head ng pangalawa plus elevation head ng ating pangalawa. Dito naman sa energy equation with turbine, when we say turbine, pinapabagal naman niya yung flow. Ay, saan ba natin makikita itong turbine na to? Mostly makikita natin turbine na to sa mga dams. Okay? Sa mga dams, in order for our dams na maging matibay, so yung flow ng tubig pinapabagal kasi kapag katuloy-tuloy yun, maaring mag-break yung dams natin and then baka bumaha sa mga area na malalapit dun sa dam. So, for our energy equation, that is the velocity head nung una plus pressure head nung una plus elevation head nung una minus the head loss minus the head extracted. Laging tandaan, pag gumamit ng pump, head added siya. Kapag naman turbine ang ginamit, head extracted. For the formula ng ating power, so depende na lang kung ano yung gagamitin. So kung pump yan, itong energy natin, this will become head added. Dito naman yung energy dito kapag turbine ang ginamit, that is head extracted. So power is equal to Q gamma and then head extracted or head added. So to appreciate our so ito muna, flow measurement devices. So marami tayong flow measurement devices. We have pitot tube, venturimeter, weirs. So for different weirs, so makikita natin yung ating lists ng ating formulas. So paki-screenshot na lang siya para meron kayong copy ng ating formula when we are solving mamaya sa ating examples. Okay, dito naman sa flow measurement devices, we have naman from for orifice, unsteady flow orifice, and for submerged flow ng unsteady flow orifice. Okay, sige. Let's solve para ma-apply natin yung mga ating mga natutunan from the fundamentals kanina ng ating formula and concept. So, first problem, water enters a pump through a 150 millimeter diameter intake pipe, leaves through a 200 millimeter diameter discharge pipe. If the average velocity in the intake pipeline is 1 meter per second, letter A, calculate the average velocity in the discharges pipeline. Letter B, what is the flow rate through the pump? For the solution, okay, list muna natin yung mga given for the first diameter, so intake pipe, that is 150 millimeter. Then for the discharge pipe, D2, that is 200 millimeter. And then yung velocity nung una natin, intake pipe, that is 1 meter per second. And then yung V2 natin, yan yung nawawala, unknown. So gamit yung ating continuity equation, we have Q na pumasok ay equals sa Q na lumabas. Okay? We can say that A1 V1 is equal to A2 V2, wherein ang ating area 1 ay pi over 4, and then take note, gawin nating meters, 0.15 squared, times yung velocity natin, that is 1, equals sa area 2 na pi over 4 times 0.2 squared times our velocity 2. So I'll give you I guess 1 minute para i-calculate ito. Okay, time's up. So we can say that our velocity 2 is 0.5625 meter per second. That is our answer for letter A. For letter B, so tinatanong lang sa atin yung flow rate through the pump. Kahit saan ka kumuha dyan, yung Q1 man or yung Q2, same pa rin yan. Sabi kasi ng ating continuity equation, yung flow rate na pumasok ay equal sa flow rate na lumabas. So, kunin natin yung una na lang kasi sa yung may known na value ng velocity. That is pi over 4 times 0.15 squared times 1 we'll get. So, I'll give you 30 seconds lang siguro to. 20 na lang. Sige, 20 seconds. Okay, time's up. So, makukuha tayo ng Q na equal sa 0.0177 cubic meter per second. That is our flow rate through the pump. Okay, if you have any question, kindly send na lang sa message. Okay, sa ating chat box here. Okay. Next problem, two pipes of diameter 175 and 225 millimeter to, class. This is millimeter, not meter. Converge into a 350 millimeter diameter pipe. If the velocity at the smallest pipe is 1.6 times the velocity of the biggest pipe, find A, the total flow rate in the system in gallons per second if the velocity at 225 millimeter diameter pipe is 4 meter per second. Letter B, velocity of the smallest pipe. Okay, sa mga ganitong problem, pag masyadong maraming word plays, ang daming mga pasikot-sikot ng problem, it is better kung isulat natin muna yung given or kung kaya natin siyang ma-visualize through drawing. So, drawing natin. For our solution, eto siya. So, this is our pipe 1. This is our pipe 2. Kinonverge. So, nag-converge sila. So, dumaan dun sa third pipe, pipe 3. So, list na natin yung given. So, the diameter 1, that is 175 millimeter. Then, diameter 2, we have 225 millimeter. And then, we have the diameter 3, that is 350 millimeter. And then, the velocities, so basahin natin na maigi. Sabi, if the velocity at the smallest pipe is 1.6 times daw nung velocity nung biggest pipe, we can represent this as V1 equals 1.6 ng V3 since nasa kanya yung largest diameter ng pipe. Then, yung V2 walang kaproblema, sinabi at binigay sa atin na that is, okay, punta muna tayo kay V3. So, for V3, we can represent that as V1 over 1.6. So, huwag kayo ma-confuse. Ang ginawa lang natin, itong 1.6, dinivide lang natin both sides by 1.6 para lumabas at maiwan tong V3. Okay? For V2, yan, walang kahirap-hirap, binigay sa atin 4 meter per second. So, ano masasabi natin dito sa flow? Yung flow na pumasok. So, pumasok siya sa 1, pumasok siya sa 2, lalabas siya ng 3. Hindi pwede na yung flow ng 1 ay, yun na mismo yung 3. Kailangan muna niya si 2 para yung flow rate nila ay maging isa papunta kay 3. We can say that the flow rate nung una plus flow rate dun sa second pipe ay equal sa flow rate nung lalabas dun sa third pipe. Okay? Therefore, we have A1 V1 plus A2 V2 equals A3 V3. So, that is area 1 pi over 4 times 0.175 squared times yung V1 natin. Okay? Sabihin na natin siyang V1. Mamaya malalaman natin kung bakit natin gagawin siyang V1 na lang. Plus, area 2, we have pi over 4 times 0.225 squared times yung ating V2. V2 natin, that is 4. Equal yan sa pi over 4 times 0.35 squared times yung ating V3 na V1 over 1.6. Mapapansin natin, this is a one equation and then isa na lang yung unknown. Okay? Kung ginawa natin tong 1.6 V3, papahirapan natin yung sarili natin. This will be one equation and then dalawa yung unknown. So, para mas madali ang buhay, V1 na lang to, V1 na lang to, para iisa na lang yung ating equation. So, I'll give you 30 seconds, I think. Or, sige, 1 minute. Para mas mabilis ninyong makuha. Okay? 5, 4, 3, 2, 1. Okay? Sige. Our answer is, pwede kayo mag-shift solve dyan. V1 is equal to 4.408 meter per second. So, medyo nakangiti tayo dapat dito kasi ang unat nating nasagutan ay yung letter B, V1. Okay? Next, so hanapin lang natin yung total flow rate. Saan niya gusto? Ang gusto niya ba yung total flow rate na kunin natin si Q1 plus Q2 or si Q3 na lang? So siguro, ang better ay since yung Q1 plus Q2 ay equal lang dun sa Q3, why not yung ating total flow rate in the system, kunin na lang natin dun sa Q3. So, we have Q3. So, kunin muna natin si V3. V3 is equal to V1 over 1.6. That is 4.408 divided by 1.6. That is 2.755 meter per second. For Q3, we have A3 V3 pi over 4 times 0.35 squared times yung V3 na nakuha natin na 2.755. Okay? That will be Q3 equals 0.265 cubic meter per second. Okay na sana to, kaso sobrang demanding nung ating problem. Sabi daw, i-convert natin papuntang gallon per second. So, dapat matandaan natin na ang isang cubic meter ay equal sa 264.172 gallons. And we will get 70.025 gallon per second. I think naka-store values ako dito. Okay, yung iba ata ay makukuha ay 70.00 something. Okay? Gallon per second. That is our answer for letter A.